Good morning, lovely 13ers. Right, buddies, here we are again with online learning. Yeah, I'm so sorry I couldn't be with you this week. I'm back again next Friday. Yeah, just the COVID track and trace app has told me that I have been in close contact with somebody who's had COVID, so I have to self-isolate. So yeah, sorry about that. I guess we'll go back to the online learning, but yeah, I guess it's got to be done to keep everybody safe. So yeah, online, woohoo, how exciting. Cool, right, my buddies, today's title is Conservation of Momentum. Now, you're going to be quite good at this. I think that this is not too bad of a topic at all. And lucky for you, I do it in a kind of different way to the book again, you lucky ducks. Just like energy, which is conserved, and you can say energy before equals energy after, uh, we can do the same with momentum. The momentum before a collision is always going to equal the momentum after a collision. So again, my lovelies, I've got another balance equation for you guys to use. Hooray! I know that makes us all very excited. So we've got F equals ma, which is like net forces, so that's a balance equation. Energy is a balance equation that we sometimes have to fiddle with for additional work added to the system and work lost to the system through resistances. So energy is the hardest. And then momentum, well, it just always works. So it's a brill one. Hooray! Okay, cool. So you've got these two equations anyway. This is your impulse equation, so it's a force. It's a force over kind of a swift time, just mv minus mu. And momentum itself has the variable p for some reason. I have no idea why, but it's got the variable p, and it's just mv. It's measured in Newton times second as well, so Newton seconds. It's just because of the ft up there. So it could be kilogram meters per second, but it's often just Newton second because that's easier to write. Cool beans. And the final thing I'm just going to show you then, equation-wise, your brand new one for today, is this. Momentum before, oh, it's a lowercase p as well, is equal to momentum after. And shabam, that's pretty much it for this whole lesson. Ooh, lesson, you lucky ducks. So let's do it. Okay. It says, in an experiment on lorry bumper design, the Transport Research Laboratory arranged for a car and a lorry, so car of mass 1 ton and a lorry of mass 3.5 tons to travel toward each other, both with speed 9 meters per second. After colliding, oh, and this part's important, after colliding, both vehicles moved together. So when they smashed, they weren't like a pool ball or a billiard ball or whatever the devil we call it in England. They weren't like that. They didn't bounce off one another, but they stuck together and moved together. So it was one heck of a good crash, it looks like. And the final question is, what is their velocity after the collision? So that's all that we're asked to do. Okay. The big tip I'm going to give you is always draw, always draw a little picture out, okay? It helps like you wouldn't even believe. You're going to want a picture. So here we go. We've got our car. Here's our car. Such a good drawer I am. Its mass is 1 ton. It says T-O-N-N-E. It's the metric ton. 1,000 kilograms. Cool? The 1,000 kilogram car is popping along this way at speed 9 meters per second. And it's going to head toward the big honker of a lorry, this big monster here, who is 3.5 tons or 3,500 kilograms. So there's where we're at. And it's cruising along this way at also 9 meters per second. So then they smash into each other. And after that, what happens is they end up smushed together into one jarbly broken mess. So that's the before picture. Here's the after picture. They're going to end up in a great big nightmarish mess. I was going to draw that crumpled, but I'm just going to draw a box. And they're stuck together. So what's their total mass when they're together? If the lorry and the car so much crashed into each other that they're stuck together, in total they weigh 4,500 kilograms. Cool? It's their combined mass. Now, it's okay to get this wrong, this next thing I'm going to do. But if you look at these two pictures, if you had a lorry smashing into a car, I have my car moving right and I have my lorry moving left. My lorry's moving left here. Which way is the wreckage going to be like careening down the road? Is it going to go to the right, the way the car was going, or is it going to go to the left, the way that the lorry was going? Yeah, the left, right? It's a great big vehicle's going to push the little one out of the way. Well, they're going to get stuck together, but that's going to be the final kind of velocity of them both. Happy days, buddies? Good. Well, let's solve it then. Here you go. We're gonna love this. You ready? Momentum before is equal to the momentum after. Okay? So here we go. Oh, I forgot something as well. You need to define a direction to be positive. Which way do you want to be positive? People usually say right, but I'm going to say left is positive, and the reason why is because I don't want to make a mistake, and I know that the wreckage is going to be moving less, so this will avoid negatives. So here we go. If left is positive, here we go. In the before picture, what we're going to have then is we're going to have P equals mv, and the mass is going to be 3,500 of the lorry, which is moving to the left, the way that we said is positive, times by 9. Take away from that, because it's moving right, the mass of the car, which is 1,000, times that by 9, and that's the total momentum before. That's everything that's happening momentum-wise. Now after, they're both in a wrecky mess together, weighing 4,500 kilograms, and we don't know the speed, it's v. Well, guess what, buddies? You can solve that in one single go now, because, yeah, we cut a bunch of steps out. We just did momentum before equals momentum after. So 3,500 times 9, take away 1,000 times 9 equals, divided by 4,500 equals, not that. So I've typed something in wrong. Of course I have. 3,500 times 9, take away 1,000 times 9 equals, divided by 4,500 equals, that's better, 5 meters per second. And that is literally it. Because it came out positive, because that answer was positive 5 meters per second, what does that mean? Well, it means it's 5 meters per second left, which is exactly what you would have expected. Now, if you made a mistake, say, well, not a mistake, say you defined your direction to be right as positive, all you'd find there, if the direction was right, is that the answer would be negative, which you'd be able to say, which means that it is going left. So you can even make a mistake in your sign convention and still get it right. Easy peasy, right, buddies? It's not as bad as the last kind of stuff. Cool! Here we go. This question is almost the same, but I only did this one because the picture made me laugh because it reminded me of back in the day. So here we go. A child of mass 30 kilograms is running through a supermarket at 4 meters per second. He leaps onto a stationary shopping trolley of mass 15 kilograms. Find the speed of the child and the trolley together, assuming that the trolley is free to move easily. Okay, using my method, I want you to pause the video right now and just do it, okay, with my method. It's the fewest number of steps and it's amazing. Are you ready? 3, 2, 1, go. Okay, and you're back then, buddies. So hopefully you'll have got this. Right is going to be positive, definitely, because all the motion is to the right. The momentum before is equal to the momentum after. The momentum that we had before was that of the kid. So the kid is M is 30 actually. The kid is 30 kilograms. And he's going at 4 meters per second. The trolley hasn't got any momentum at all. I'm just going to write it. You don't have to write this. You shouldn't write it. But the trolley doesn't have any speed, therefore it doesn't have any momentum. So, in other words, why don't we just bin the trolley off? We don't need the trolley. So, yeah, it's not got any momentum. Afterward, though, the kid and the trolley are together because they've attached themselves. So that's 45 kilograms. The kid's on the 15 kilogram trolley is the 30 kilogram kid, so that's 45, and we don't know how quick he's going, so V. Look at that, one step. Isn't this beautiful? My gosh, lovelies, you lucky ducks. It's just going to be 30 times 4 equals divided by 45 equals, and it's 2.67, bish bash bosh, 2.67 meters per second. Is positive. The direction I said was right is positive, so it's right. Cool. It's important that you realize that momentum is a vector quantity, so direction does matter, and you should be including your directions and stuff in your final answer. I don't think you'd lose a mark, but yeah, still, just to be safe. Cool? Easy peasy lemon squeezy? Cool. They can get way harder than this, okay? So you can get that so that say it was two pool balls hitting each other and they each bounce in different directions, you could get that. You could get pool balls bouncing off walls. There's lots of different stuff you can get here, but these are kind of easy ones today. Cool! So for our very last question, my lovelies, which has magically just gained these little pictures and also gained a change in time at the bottom corner, it's a question about firing a rifle. How seamless is my editing transition? Cool. So here we go, buddies. It says a rifle of mass 8 kilograms is used to fire a bullet of mass 80 grams at a speed of 200 meters per second, and it wants you to calculate the initial recoil speed of the rifle. Cool. So you might be thinking, why did I pause the video and add these pictures in? Because I started rambling, and then I thought, why don't I just edit the video and just tell you guys what I want to tell you? Cool. This one's weird, this question, okay? Because at the start, when the bullet is in the gun, there's no momentum at all, right? Because it's just a bullet sat in a gun. The gun's not moving, the bullet's not moving, no momentum at all. However, after the gun gets shot, the bullet obviously goes out in that direction that it was shot in at 200 meters per second, but the gun will actually jump backwards. Now, I've never actually fired a gun before, so I don't really know 100% what I'm on about here, but I know from movies, and I wanted to find these pictures online to show you what happens. But did you know that when people actually shoot guns, like especially big ones, like this lady down here with the shotgun or whatever she's got, see how she's got it propped up against her shoulder like that? Well, actually, she's going to shoot a bullet forward to the right, as like seen in the picture. That's going to cause the gun to actually push back really hard into her shoulder, so much so that she's actually fallen backwards in this picture. Cool. It works with little guns too. See the pistol, how it jumps up, and the guy's hand has to hold it really tightly to keep it kind of from flying back even further. That's the kind of thing I wanted to talk about, so I hope that was worth pausing the video for. But yeah, guns move backwards when you shoot bullets forward. You may not have thought of that before, but they do, so hooray! Cool. So let's try to solve this questions then. So here we go. Works exactly the same as all the others. So number one, let's start off with the sign convention. I'm going to say that right is positive, because if I sort out my sign convention early, then I can just ignore kind of positive and negative throughout the question, and that will be that. So here we go. To begin with, we're going to have the momentum before equaling the momentum after, just like last time, but this is weird. This time, initially, before the bullet is fired, it has no momentum at all. Okay, so there's no momentum because the gun's not moving and the bullet's not moving. Zero. Afterward, though, here's what we've got. We've got the bullet moving forward, so it's MV. The bullet is 0.08 because we divided 80 by 1,000, and it's going off at a speed of 200, and that's to the right. However, here we go. I'm going to deal with the difference in direction right now. Because the gun's going to move backwards, I'm going to put a minus in here on the understanding that that means that the V that I'm going to get as my answer here is going to be in the backwards direction. It's going to be to the left. So here we go, buddies. I've dealt with the sign convention, or I've dealt with the negative that I would have got using the sign convention. So here we go. It's going to be 8 times V, and that's all there is to it, buddies. You just have to rewrite it, rearrange, and go. So here we go. V equals, and let's do it. 0.08 times 200 equals, divided by 8 equals 2 meters per second. Now, that is going to be the recoil speed of the gun. So in other words, the gun is going to move backwards by 2 meters per second. That's going to be the speed that it jumps backwards with after firing. Now, because of the way that I do these things, can you see that I put a minus in there? I've dealt with my sign, or I've got the fact that it's left already dealt with by putting a minus in here. If I wanted to achieve a negative answer, I'd have had to say that both of them are plus. It's a total momentum question, but I think it's easier just to go with dealing with your sign convention as you go along. Then directions don't matter anymore once you've got that. So the total speed that you're going to get there, the recoil speed of the gun, 2 meters per second left, which of course it is, opposite to the direction of the bullet. So hopefully that's that. Hopefully you feel okay at it. Momentum, conservation of momentum, very cool. And that's it for today. Cool. So all I want you to try, buddies, is these guys here. is page 136, question 1 to 13, but do a mix, okay? So don't just do every single question. If you feel like you want to go into yellow ones to begin with, please go ahead and do that. If you want to try red ones, do that as well. Spend only just the rest of this period plus another, I don't know, 10 minutes or 20 minutes max on this to keep your practice up. And that's it for today, my lovelies, so see you next time. Bye, buddies!